The sun, our Daystar. The sun, a blazing ball of plasma, is our constant companion. It is the ultimate source of energy for our planet, bathing us in its warmth and light. As it begins its descent, a remarkable transformation occurs. The sun seems to change color, shifting from a bright white to a warm, inviting red. But what causes this dramatic shift in the sun's appearance? A kaleidoscope in the sky. As sunlight enters the Earth's atmosphere, it encounters tiny particles, nitrogen and oxygen molecules, water droplets, dust, and pollutants. These particles scatter light in different directions. Shorter wavelengths such as blue and violet are scattered more effectively. This scattered blue light gives our sky its characteristic color during the day. As the sun descends, its light travels through a greater thickness of the atmosphere. The shorter wavelengths are scattered away, leaving behind the longer wavelengths of light, oranges, reds, and yellows. Imagine the atmosphere as a giant prism, splitting the sunlight into its constituent colors. The result is a breathtaking display of color, a celestial canvas painted with hues of orange, red, pink, and purple. Rayleigh scattering, the science of color. Rayleigh scattering explains why the sky is blue, why sunsets are red, and why clouds appear white. It's a fundamental principle of atmospheric optics. Rayleigh scattering is most effective when the particles scattering the light are much smaller than the wavelength of the light itself. This is why nitrogen and oxygen molecules are so effective at scattering blue light. The intensity of Rayleigh scattering is inversely proportional to the fourth power of the wavelength of light. Blue light, with its shorter wavelength, is scattered much more strongly than red light. As the sun sets, the angle at which sunlight enters the atmosphere changes. This increased scattering of shorter wavelengths gives sunsets their characteristic red and orange hues. The long and winding path of light. Imagine a beam of sunlight entering the Earth's atmosphere. As it collides with air molecules, the blue light is scattered in all directions. Some of this scattered blue light reaches our eyes, making the sky appear blue. As the sun dips lower, the path of this light through the atmosphere lengthens. More of the blue and green light is scattered away, leaving behind the longer wavelengths: oranges, reds, and yellows. The exact colors of a sunset can vary depending on factors like the amount of dust and water vapor in the air. Volcanic eruptions can lead to particularly spectacular sunsets. Pollution can also impact the colors of the sky, sometimes leading to hazy or muted sunsets. Section 5. Blue skies and red sunsets. Two sides of the same coin. The same phenomenon responsible for the blue of our daytime sky also paints our sunsets in hues of red and orange. Rayleigh scattering transforms our everyday experience, adding a touch of magic to our skies. The next time you gaze upon a vibrant sunset, take a moment to appreciate the science behind this celestial spectacle. It's a reminder of the vastness of the universe and our own place within this grand cosmic tapestry. The beauty of a red sunset extends beyond its scientific explanation. It's a source of inspiration, a reminder of the ephemeral nature of time, and a symbol of hope and renewal. Sunsets have been immortalized in paintings, poems, and songs, capturing the human spirit's enduring fascination. They remind us of the beauty that surrounds us, even in the face of life's challenges. Section 6. The setting sun, a dance of colors. The colors of a sunset shift and evolve as the sun continues its descent. At first, the sun may appear a brilliant yellow. As it dips lower, the yellow deepens into orange, then red. The sky around the setting sun can erupt in a kaleidoscope of colors, with hues of pink, purple, and even green. Clouds can reflect and scatter the colors of the setting sun, creating breathtaking displays of light and shadow. A single cloud can be painted with a spectrum of colors, transforming the evening sky into a work of art. As the last sliver of the sun dips below the horizon, the sky often erupts in a final burst of color. The colors of a sunset reflect off bodies of water, transforming lakes, rivers, and oceans into shimmering mirrors of the sky above. Section 7. Beyond the visible, the sun's hidden spectrum. While our eyes perceive the setting sun as a symphony of reds, oranges, and yellows, this is only a small fraction of the light it emits. The sun radiates energy across a vast spectrum, from radio waves to gamma rays. Our atmosphere acts as a filter, blocking most of this radiation and allowing only visible light to reach the surface. During a sunset, the path of sunlight through the atmosphere lengthens, absorbing or scattering more radiation. This is why sunsets can sometimes appear dimmer than the midday sun. The longer path through the atmosphere allows for greater absorption of light, particularly by ozone and water vapor. This absorption of radiation is essential for life on Earth. Section 8. Atmospheric canvas. Painting the sky with particles. The exact colors and patterns of a sunset are influenced by the composition of the atmosphere. Dust, water vapor, and even pollution can act like tiny prisms, scattering and absorbing sunlight in unique ways. A sky filled with dust or smoke can create particularly vibrant sunsets. Volcanic eruptions can lead to spectacular sunsets around the world. High humidity can lead to hazy sunsets, muting the colors. Clouds can reflect and scatter the colors of the setting sun, creating dramatic displays. Even pollution can contribute to the beauty of a sunset, enhancing the reds and oranges. Section 9. A global spectacle: sunsets around the world. While sunsets are a universal phenomenon, their appearance can vary depending on location and atmospheric conditions. Sunsets near the equator tend to be shorter and more intense. In polar regions, sunsets can last for hours, creating prolonged displays of color. Coastal areas often experience particularly vibrant sunsets, with stunning mirror images on the water. Deserts are known for their spectacular sunsets, with vivid reds and oranges. Sunsets have the power to captivate us wherever we are in the world. Section 10. The sun's farewell, a reminder of our place. The setting sun is more than just a scientific phenomenon. It's a reminder of the passage of time and the preciousness of each passing moment. As the sun dips below the horizon, it signals the end of the day, a time for reflection, rest, and renewal. The setting sun also reminds us of our place in the cosmos. Despite our insignificance, we are capable of experiencing moments of profound beauty and wonder. The setting sun can help us to live more fully in the present moment, appreciating the fleeting beauty of life on Earth. Section 11. Epilogue. The enduring allure of the red sunset. The red sunset continues to captivate and inspire us. It's a testament to the power of nature, the elegance of science, and the enduring human spirit. As we gaze upon this daily spectacle, we are reminded of the interconnectedness of all things and the preciousness of our own existence. May the red sunset forever serve as a source of wonder, inspiration, and hope, reminding us to cherish each passing moment.